Hi, I'm Charan, and I'm recording this video as part of ICP1 for Big Data Analytics. So the ask for this assignment is to create data analysis for three types of data analysis for the given data. The first one I'll be doing is correlation analysis to know how the features are correlated with the targets. Just walking through to the code. This is where I'm loading the data as data frame and remove the ID column because this is not the suitable feature that would be useful for the prediction or how correlation does happen. And with diagnosis as target, I'm generating the heat map. Using the heat map, I'll get to see what is the most correlated feature and what is the less correlated feature. Just running through the code. So this shows the heat map, and this is the diagnosis. This is if it's considered V as a target value. This is the least correlated, and this is a positive correlated values. We can see that dimension mean and area SC, these are the few things that are majorly correlated to the diagnosis values. As we see, not many features are positively correlating, so there is not a single feature that works as a stronger correlation factor for this data. That's an observation for the first types of analysis. And the values are now stored here as a plot just for the future reference. Second one, this is a way of clustering and seeing how the data behaves. If we are given the data type as a binary cluster 1 and 2 M and B, but looking at this, the behavior of data, how many clusters are better suitable, or to see how many clusters are well formed. If you see here with 2 clusters, there's a sharp increase showing that this is the best clustering possible. But if you see the rise from four clusters, that shows the behavior of this data also shows there is a possibility of having 4 clusters with the data that is presented with. But of course, it is performing very well if you are having 2 clusters with a sharp increase to the inertia. Considering of that, I've also taken this data and put that through the PCA for reducing the dimensions about 30 features to 2-dimensional features, 2 PCA dimensional features. Once I'm plotting these PCA features against a graph, I could see there's a clear line of difference between class 1 and class 2, which means looking at the class 1, reducing this type of data with PCA has been proven as most meaningful for this data, which shows a clear difference between benign cancer and the malignant cancer. So this is one of the statistical analysis that I performed as part of this task. And the last one is a pure statistical foundational analysis, that is like mean, sum, count, standard deviation. So I've considered mean for this analysis. Running through the mean, if I was able to generate the values that we are talking of. Considering mean for these values, where benign is orange and malignant is blue, we could see the area mean, area SC, and area worst are the most highest values for within the given set for this analysis. But the rest of the other features are negligible. But mind you, there is a pitfall. It's a mean level analysis. The higher level of values of the mean average values doesn't mean they are highly correlating to the target values. This shows these are the actual significant values in terms of calculations, but that is not directly proportional to the correlation, because some values can be very small between 0 and 1, but they still play a major role while contributing to bringing out the diagnosis decision. So these are the 3 types of analysis that I did as part of ICP1. Thank you very much. This is Charan again.